Our planet's magnetic shield is under threat, and the consequences could be dire for space exploration. But here's the twist. This isn't a sci-fi plot. It's a real-life concern backed by over a decade of data. Recent measurements from 3 European Space Agency, ESA, satellites, collectively known as Swarm, have revealed a growing weak spot in Earth's magnetic field over the South Atlantic Ocean. This region, dubbed the South Atlantic Anomaly, SAA, has expanded by an area comparable to half of Europe since 2014. Simultaneously, a strong magnetic field region over Canada has shrunk, while another in Siberia has grown. Earth's magnetic field, or the geomagnetic field, is our planet's protective barrier against harmful solar radiation. It's generated by the molten iron core deep within the Earth, approximately 2,900 kilometers beneath the surface. However, the field's strength fluctuates, and its exact mechanisms remain a mystery to scientists. The geomagnetic field is vital for life on Earth, shielding us from the charged particles in solar radiation. We witness its interaction with the sun's particles during the mesmerizing aurorae, like the northern lights. But its role extends beyond our atmosphere, protecting spacecraft and astronauts in low Earth orbit. And this is where it gets concerning. The expanding SAA weakens this protection, exposing satellites and astronauts to increased radiation. This radiation can cause malfunctions, damage, or even blackouts in spacecraft hardware. But wait, there's more. Humans in orbit face heightened risks, including a greater chance of DNA damage and cancer. The intensity of the geomagnetic field is relatively weak, ranging from 22,000 to 67,000 nanoteslas, compared to a typical refrigerator magnet's 10 million nanoteslas. In the SAA, it's even weaker, below 26,000 nanoteslas. Since 2014, this weak spot has grown by almost 1% of Earth's surface area, with the weakest point dropping to 22,094 nanoteslas. The study's authors suggest that spacecraft designers should consider these findings when planning future missions. They propose hardening spacecraft to better withstand the increased radiation in the SAA region. While the study doesn't indicate an imminent magnetic field reversal, it highlights the field's dynamic nature. Geophysicist Hargri Amit, who has studied the SAA, emphasizes the importance of continuous high-quality geomagnetic measurements to understand the deep Earth's dynamics. But here's where it gets controversial. Could this be a sign of a more significant shift in Earth's magnetic field? Are we witnessing a fluctuation or the prelude to a reversal? The debate is open, and the implications are vast. What do you think? Is Earth's magnetic field in a state of flux? And what does this mean for our future in space?